This slide will be kind of marking a transition, you know, where are we right now? That's who's here in the room. You saw the answers to those questions. Where are we? Very briefly, some of you know this better than I do, so I'm not going to kind of inflict my perspective, except to spend maybe a minute on this. If you imagine a sort of a rainbow, you know, of progress from somewhere in the mid 1900s reaching into this decade, Web 0 shrunk computers down from the size of a house to the mobile phone in your pocket that is always connected with high-speed internet. The readable web, maybe starting with ARPANET through universities, you know, Encyclopedia Britannica Online and AOL, down to you can ask Siri today for the weather tomorrow, and Siri will read the web to tell you. The writable web, starting with maybe bulletin board systems in the 80s, through you know, HTTP, HTML, CSS, a little bit of JavaScript or whatever to make things blink, and then social networks to TikTok and what's the thing everybody's on today? The perpetual phone call. People spend like 5 to 10 hours a day talking about blockchain on it. I can't remember. Maybe one of you knows the name of
Clubhouse.
This. Clubhouse, yeah. So there's the writable web for you, and the trusted web, starting in maybe you could say 1976 with Diffie-Hellman's paper and crediting Merkle for public key cryptography, Chom in the early 80s with a bunch of ideas that led effectively, I think, to something he called eCash, and then Hashcash with Szabo, Nick Szabo's Hashcash, Adam Back and some of his you know, work, conversations with Wei Dai and B Money, some people, you know, calling him Satoshi. 2008, a paper getting published that basically combines you know, BitTorrent, sort of decentralized computing and storage, cryptographically verifiable signatures and transactions, and a triple ledger, public ledger. So not the single ledger, the double ledger of you know, the last few hundred years, but a triple ledger with a public copy. Those three technologies together form Bitcoin. And then on top of that, Ethereum with a Turing complete virtual machine, and now with, you know, the half dozen or dozen organizations competing to solve scalability and speed and cost. So that's the trusted web, effectively a layer on top of which we can put anything we care about, because this layer makes it too expensive to lie. It is effectively the truth. Some people call it a trust machine, and on top of this thing now we can basically put you know, things like identity, money, ownership, provenance, all the stuff. Provenance is like, you know, where did something come from, all of the things that actually matter to us as human beings. And the idea is that this is potentially transformative. If you watch the videos in the day zero, there was a series of 4 or 5 videos that would basically paint this picture for you. And so what we've got now is DAOs, token economics and mechanism design, basically starting backwards with, you know, how to create incentive systems, and total disintermediation. You know, a civics API that lets you decide how you want to help out in the local government. Maybe, you know, you can request a speed bump as easily as you can, you know, I don't know, file a report about having seen some bird somewhere that shouldn't be there. Border API, where we can programmatically, you know, enhance border crossings in ways that are amenable to us or localizable. Effectively a humans API with incentivization programs. But now I'm just waving my hands around. I don't actually know what I'm talking about. So if you kind of look at the market, Bitcoin, we just talked about this cryptographically verifiable transactions, decentralized storage and compute, and a public ledger. Ethereum is Bitcoin technology plus the Turing complete virtual machine with on-chain inputs and outputs, the code and the data being saved on chain. The problem here is that it's expensive, low throughput, and hard to scale. And so Near, Polkadot, Solana, Avalanche, and others are solving this. You know, Cardano, Dfinity, well, anyway, lots of others. I guess about 10 or 15 companies. Some of you probably know this list better than I do. And a huge grain of salt, please, with this image, because I got some serious pushback from folks on the team that this is a ridiculously simplified picture and almost doesn't make any sense. So please forgive me, but I do think it's useful in the sense that if you think about sort of how these different organizations are trying to scale, Near has these transactions coming in. The transactions get routed to a different shard depending on the receiver account. I know the most about Near, obviously. And then that creates what's called an action receipt in that the next block that's available. That action receipt might generate multiple other action receipts across contract calls, basically across shards, which are then resolved into data receipts to get back the result to whoever the caller was. And again, overly simplified mechanism here, but that's basically the scalability story is the yellow highlighted multiple shards in Near. Currently mainnet's running on one shard.
Okay.
Before the end of the year, it'll be running on, I guess, 8 shards or something like that. Sorry, somebody had a question? No? Okay. Yeah, feel free to interrupt, by the way, highly interruptible. So just because I like to hear the sound of my own voice doesn't mean you can't stop me and say something. So Polkadot taking in transactions to different parachains, while on Near, each shard is homogeneous. It's the same kind of transactions, but basically scaling outwards. In Polkadot, the parachains are heterogeneous, meaning they're different. They could have their own economy, their own token, their own dynamics, their own rules. And that's one of the strengths of Polkadot is you can basically design your own blockchain and then hook it up to the relay chain. And their scalability story comes from these parachains, 50 to 100 parachains, whatever you can add. And then more so secondary parachains. So this kind of goes out, if you imagine like a fractal tree kind of growing out at the leaves with parachains. I don't know how many layers it goes, maybe 2 or 3, I'm not really sure, but I've only seen mention of secondary parachains. In the end, it's a pretty big scalability story. Solana, their scalability story is in parallelizing work that has been predetermined in terms of time. So there's a leader that basically timestamps every single transaction as it comes through. That's the little timer right there. Then things get parallelized, transactions, they get processed in parallel and then aggregated by something, I guess, called an archiver, where you can see transactions 1, 2, and 3 are sequenced now in the proper order, okay? Again, if you know more about this than I do, I need you to say something, in Discord or in this meeting and say, you know what, that's totally wrong. I'll get you a better picture. I would be so grateful to you. This isn't about what I know. This is about framing the conversation, okay? Avalanche here basically specializing 3 different chains, C chain for, EVM related work like Ethereum, an X chain for token exchange, token economics, that kind of stuff, I guess, and then a P chain for governance related work. Different chains, they don't talk to each other, is my understanding. They kind of do their own thing. And there was some news about the C chain recently, for example, that was, recovered very well and all sorts of sort of activities. So if you hear about that or you read about Avalanche in the news, for example, this will give you a mental model for what's happening there. And obviously the team, is handling that as effectively as any of these other teams are. So it's so far it seems like everybody's got an interesting story. And again, this is not potentially accurate, and it's certainly not complete. There's a lot more detail to all of this stuff. I just wanted to give you something to hold on to, like what are people doing to try and solve this problem, and here's my thinking on it.